Welcome back. This problem, you have given a DAG with n nodes. The nodes are labeled with 0, 1 up to n minus 1. So return all paths from node 0 to n minus 1. You need to return all paths which are starting from 0 and ending at n minus 1. It is a DAG, so it will be kind of a tree model. You don't have cycles. So if there is any path from 0 to n minus 1, it should be definitive. So the constraints of the problem are very lightweight. You have only 15 nodes. So you can do some kind of, you will have some leisure memory and time constraints. So it's okay to have do complex thing with complex time memory consuming things in your solution. So how to approach this is like we can have some sort of breadth first. With every search node, you can append the search path covered so far. And if the search hits at a target node, target is n minus 1, record that into your answer vector. This will be your answer vector. And finally return the answer. So you need a queue. Let it be pair of int means the node you are exploring. And a vector of int means the paths you had explored so far. Then insert, you will be starting from 0. So vector will be correctly 0. This is your breadth first search part. So while the queue is not empty, you will be picking the front of the queue, picking elements from the front of the queue. We'll name it a front first. Then you require the paths you had traveled so far. Queue dot front dot path. There is something wrong with this. Okay, you have closed the previous state. Okay, now you will check. You have to check if the front has hit n minus 1. Is it the last one? Is it the last node? Is it a target node? Then enqueue the path traveled so far into your target container, result container. You haven't defined the n. Okay. Now you have hit your last node. If it is not hit, then you have to further do a kind of exploration of the neighboring nodes where you are currently in. From where you are currently in. For that, next node, graph is a adjacency list, so you can directly explore it. So you might require some kind of the happiness of DAG is you don't require a visited node. It will be always taking you ahead of the process. So just enqueue. You have your path dot push back your next element. Then queue them. Your next element and the path. Queue them. Then path dot pop back. So this is the result you can expect. Is there anything missing? Do we need any check for the next? Okay. I think this should be enough. Let's have a trial of the solution. It's not coming out. It is stuck somewhere in infinite queue. Let me see the reference. Correct only. So we initialized the queue. We declared the queue. We initialized the queue with some data. The data came here. Yeah, here we are not popping the queue out. Pop. Okay, this should work, I guess. Must be. How do? Oh, 1, 2, 3. That's the truth. That's the truth. The first set of answer from 0 to 4. 0 to 4, there is a path. 0, 3, 4. Yeah, all these answers are correct. This path is there, 0 to 4. From 0, you can go to 4. 0, 1, 2, 3, 4. Yeah. From 0, you can directly go to 4. From 0, you can go to 3. From 3, 0, 1, 3. 3, you can go to 4. So all these answers are valid. And here, from 0, you can go to 1. From 1, you can go to 3. From 0, you can go to 2. From 2, you can go to 3. So all these answers are correct. That's how we solve this problem. Hope you understood.